Design and implementation of novel-based framework for MANETS. Abstract, Intrusion Detection System, IDS, is a famous approach for finding attacks in anomalies. This system is used for monitoring the attacks happening in mesh or computers. The anomaly intrusion detection technique plays the significant part in the intrusion detection systems to recognize the recent or novel attacks by identifying any variation from common profile. This research provides the proof for enhancement of anomaly intrusion detection. The introduced method improves the security by using anomaly-based intrusion detection process and zone-based Aodv routing protocol to discover shortest path. First, it contains selection of the features for anomaly IDS. Next is essential to identify the novel or recent attacks by achieved decision rules from database. Keywords: A anomaly-based intrusion detection technique and security mobile ad hoc network, MANETS, zone-based Aodv routing protocol. Introduction. Mobile ad hoc networks, MANETS, contains mobile node interrelated by wireless links in communication-less atmospheres with no relying on any federalized power like base station as shown in Fig 1. The nodes which will not be inside the communication range of one another, will converse by intermediate nodes known as the relay nodes. The mobile ad hoc networks are organized in the regions or such conditions where communications is not accessible or when operation of communication is not possible or costly, like environmental disasters, emergency operations, etc. Because of the distributed architecture, dynamic mesh topology and the non-appearance of the centralized authority, the MANETS are helpless to the packet routing attack. The MANET is a self-structured grouping of mobile nodes which will converse with each other without the assist of any permanent infrastructure or central coordinator. A node is any mobile device with capability to converse with another device. The node acts as router and also host in MANET. A node planning to converse with other node that is not within conversion range, then it will take the help of intermediate nodes to send out its message. Network topology is robustly modified over time as nodes travel about. Several novel nodes link the network or some nodes separate themselves from network. Mobile ad hoc network may be a multi-hop wireless network, whenever nodes converse with each other without previously organized infrastructure. With non-existence of previously recognized infrastructure, for example no access purpose, no router etc., two nodes converse with one another in an extremely peer-to-peer manner. When two nodes converse straightly inside transmission, it differs from all dissimilar nodes. Or else, nodes converse through multi-hop route with assistance of dissimilar nodes. In the MANET, it contains self-organizing, self-administrating and self-creating capacity. For example, disaster relief, embrace field of honor condition and shortest conditions like public events. Limited information measure, frequent vary in topology, process capability, and restricted storage of MANETs have increased a lot of challenges for researchers of network. In every required challenge is to create a support for time period multicast communication. Ad hoc networking is a promising technology that permits every node to join by wireless communication links, without any base station. These networking have some features: energy, bandwidth, and physical security are limited to topology dynamics. Hence the routing protocols utilized in wired network are not matched for the MANET. The IDS is a practice of examining the events happening in the computer or mesh and examining them for the signals of the intrusion. The IDS is intended to care the availability, confidentiality, and integrity of significant networked information system. The IDS is the method that combines and evaluates information from the different regions contained by the mesh or computer to recognize the attacks prepared against these components. Intrusion Detection System utilizes number of general processes for examining the utilizations of vulnerabilities. Fig 1. Mobile ad hoc network. The IDS is mainly a security system of network system which identifies any harmful behaviors and raise an alarm so that protecting measures are taken to avoid attack. The IDS is categorized into two categories, which are signature detection and anomaly detection. Signature detection method is dependable in nature since it is deterministic. It utilizes patterns of well-known attack to recognize identical intrusions. Although this technique has some disadvantages, that it is impossible to detect unknown attacks, a dataset is necessary for it, which makes it complicated to maintain and also time-consuming. Alternatively, anomaly-based IDS can evaluate among anomalous and regular behavior of a network scheme. Thus, unlike signature detection, this anomaly detection technique works well for known as well unknown or new attacks. But drawback of this detection method is that, it excludes identifying the actual attacks. It can also raise few fake alarms where the intrusions are not occurred. In this paper we are detecting the attacks on MANETS by using zone-based Aodv protocol. From the Aodv we are finding the shortest path for communicating the source and destination. There are many types in Anomaly Intrusion Detection System. In this proposed system the buffer overflow is detected using suitable techniques. Literature survey. Shi Weilin et.al01 introduced a technique with the feature collection and decision rules used for anomaly IDS. The aim is to obtain advantage of the decision tree, DT, simulated annealing, SA, and SVM. In introduced algorithm, the SA and SVM can discover top selected characteristics to promote the accurateness of anomaly ID. With analyzing information from utilizing the KDD99 dataset, the SA and DT will get decision rules for recent attack and be able to develop the accuracy of the categorization. The good parameter settings for support vector machine and DT are routinely adjusted by the SA. The result of simulations shows that introduced technique is victorious in identifying the anomaly IDS. Zhou Mingqiang et.al05 proposed graph-based IDS by utilizing the outlier detection system based on the LDCGB, local deviation coefficient. Evaluated with the other intrusion detection techniques of clustering, this technique is needless to early cluster number. For now, it is strong in outliers affection and capable to identify any figure of the cluster sum with that the circle 1 only. Furthermore, it still contains the steady rate of recognition on muted or strange attacks. The LDCGB utilizes the graph-based cluster technique to achieve the primary division of the dataset. This will be based on cluster precision parameter quite than the primary cluster number. Alternatively, due to these, IDS is depending on dataset of mixed training, hence it should contain high accuracy to warranty its presentation. Thus in phrase labeling, the algorithm forces outlier detection technique of local variation coefficient to tag the GB algorithm result. This calculation is capable to develop accuracy of labeling. After the algorithm is tested by the KDD-CUP99 dataset, the false positive rate, 2.24%, and detection rate, 93.30%, are achieved. The result of the experiment expresses that the introduced algorithm can achieve a reasonable performance. Robin Sommer et.al02 studied the differentiations among the system intrusion detection issue and different regions where machine learning frequently finds great achievement. Their important state is the duty of discovering attacks is essentially dissimilar from other applications, making it considerably difficult for intrusion detection area to make use of machine learning successfully. They maintain this state by recognizing challenges exacting to network intrusion detection and give a set of instructions aimed to make stronger future research on the anomaly detection. Jianqinhu 04 introduced the essentials of HIDS and the famous HIDS were examined. Some performance aspects were given and talented HIDS technologies were examined. A novel framework is introduced to add the multiple detection engines. Some systems under this framework are advised. They consider that in addition to scheming novel individual detection engines and getting better presently active detection engines, much effort is essential to improve novel schemes or architectures like a variety of benefits of individual detection engines can employed successfully. Introduced work is efficiently observe anomalies with higher detection rate, lower false positive rate and methodology. The Fig 2 depicts block diagram of proposed scheme. Here the first step is initialize network, that is selection of source node and destination node to find some node parameters. A zone-based Aodv protocol is utilized to choose path among source node and destination node or for communicating source and destination node. The source node will transmit RREQ, root request, message to destination node. When RREQ message is reached to destination node, the path will establish among source and destination. The node at destination will transmit RREP to source node and then source node will transfer data packet to destination. This zone-based protocol partitions complete network into zones. It makes use of any reactive or proactive protocols inside and among zones. Intra-zone routing is presented generally by proactive protocol, thereby decreases delay to communicate to nodes inside network. Inter-zone routing protocol utilizes reactive protocol, this ignores the need to keep proactive fresh state of the whole network. By using the FSM, finite state machine, verifying the RREQ and RREP messages, then the anomaly IDSs check that the nodes are anomaly behavioral or not. Here the buffer overflow attack is detected. The buffer overflow attack is a kind of anomaly. If the anomaly behavioral nodes or buffer overflow attacks are present in network, an alarm will be generating. If not, it will forward data packet to next node or destination. Aodv routing protocol. For the wireless ad hoc network, the Aodv, ad hoc on-demand distance vector, is a routing protocol. It's a reactive protocol that will find out a route to destination only when it is necessary. In Aodv, the knob that wants an association sends out a route request message that is RREQ. Every nearest node can achieve one of below given two actions. Send the RREP, that is route replay message, to source node, suppose it is previously contained the route. Make the way inside its routing chart regards the source node, increase the hop count in route request message and retransmit route request message to its neighbors. The RREQ arrive at destination or several intermediate nodes, which contain fresh route to destination and robotically generates the repeal path. The route replay message follow reverse path and sets up forward pointer for data packet to the destination. Once source gets a route replay message, it will begin to sending the data packets. Suppose later on source receive the route replay message containing a higher series number or the similar sequence number with the fewer number of hops, it will modernize its routing chart and begins utilizing best route to destination. Suppose a link break happen, the upstream node transfer a route error message that is RERR to source node and discovery of route is reinitiated at source suppose needed. The RREQ, RREP, and RERR etc. messages are concluded by the series numbers employed in the messages. The node increases the series number of the message, before sending the any kind of routing control message. The highest series number specifies much fresh information. When a node obtains multiple control messages, one with the highest series number is measured more up to date and it is utilized in route organization by the other nodes. RREQ message and RREP message. Route request, suppose there is no route for destination, a route request message, RREQ, is sent throughout the network. The route request contains the following phases, which is depicted in Table 1. Can contact every levels, mainly the top level. The nodes related to altered subnets should transmit their communication to a subnet that is general to both nodes. This might block the network parts. The ZRP is considered as flat protocol because the zone overlaps. Therefore, finest routes can be recognized and network jamming can be decreased. The behavior of ZRP depends on the present configuration of network and user's behavior. Anomaly-based IDS. The capability of the approach to recognize the intrusive or slightly irregular behavior is a foundation of anomaly-based intrusion systems. Initial problem in this position is the meaning of the anomaly. The regular understanding of anomaly as activity dissimilar from the common brings many challenges in the practical settings. The intellectual research largely describes anomaly as an irregular behavior, for example outlier. The anomaly-based detection depends on statistical behavior modeling. Common operations of the members are profiled and some quantity of variation from the zone routing protocol. Zone routing protocol, ZRP, joins the benefits of reactive and proactive approaches by preserving an up-to-date topological map of the zone centered on every node. Inside the zone, the routes will be instantly obtainable. Outside the zone, the ZRP utilizes the route detection processes, which can profit from local routing information of zone. Reactive and proactive routing contains particular advantage and disadvantage that create them suitable for definite types of scenarios. Because reactive protocol should initially resolve the route, which might be the result in the significant delay, suppose the information will not obtainable in the cache. On the opposite, the proactive routing preserves information that is instantly obtainable and the wait before transmitting a packet is minimum. The proactive routing utilizes extra bandwidth to maintain information of routing, whereas reactive routing includes lengthy route request delay. The reactive routing in addition wastefully overflows the total network for the determination of route. The ZRP intended to address issues by adding the better properties of together approaches. Zone routing protocol is classified as hybrid reactive or proactive routing protocol. In the Ad-Hoc network, it is believed that the biggest part of traffic is fixed to nearer nodes. Hence, ZRP decreases proactive range to the zone centered on every nodes. The protection of routing. Common activities is ensign as an anomaly. The weakness of this anomaly IDS is that the common profiles should be modernized regularly, because the presentation of network may change quickly. This might increase the load on the resource-controlled sensor nodes. This system will recognize the intrusions in a more ideal and steady way under the situation that the network being monitored follows statistic behavioral patterns. The benefit of this anomaly intrusion detection technique is that it is much suited to recognize the unfamiliar or attacks which are not encountered before. Anomaly detection technique generates a common baseline profile of common behaviors of mesh traffic activity. After that, the behavior that moves away from the baseline is considered as a possible intrusion. Major cause is to assemble set of helpful characteristics from traffic to decide the decision that sampled traffic is abnormal or normal. Few benefits of anomaly recognition technique are: it will recognize insider attacks, it is tougher for attackers to carry attacks without fixing off an alarm, and it can detect unknown or new attacks 07, 09, and 10. The anomaly detection is based on defining behavior of the network. The behavior of the network is in accordance with previously defined behavior, then it is accepted, or else it triggers event in anomaly detection. Accepted network behavior is learned or prepared by specification of network administrator. Significant stage in defining network behavior is intrusion detection system engine ability to cut throughout different protocols at every level. Engine should be capable to know its aim and procedure protocols. Although this investigation of the protocol is computationally pricey, the advantages is it produces rising rule set like assist in lesser false positive alarm. Defining its rule set is an important disadvantage of the anomaly detection. The effectiveness of method depends on how nicely it is tested and implemented on every protocol. Rule-defining procedure is as well as pretentious by dissimilar protocols employed by different vendors. Excluding these, custom protocols as well create rule-defining a complicated job. For recognition to occur properly, the complete knowledge regarding accepted network behavior require to be implemented by administrators. But one time the rules are explained and the protocol is constructed, then anomaly detection techniques will work properly. Main benefit of anomaly detection over the signature detection is that a new attack for which a signature will not exist is identified, suppose it falls out of standard traffic patterns. This is monitored when system detects novel automated worms. Suppose novel technique is spoiled with a worm, it generally begins scanning for other susceptible techniques at an accelerated rate, filling network with malicious traffic, therefore causing event of a TCP bandwidth or connection abnormality rule. There are many attacks in anomaly IDS. The anomaly intrusion detection is helpful for identifying attacks like buffer overflow, misuse of protocol and service ports, dose based on crafted payload, dose based on volume, other natural network failure. The above mentioned attacks are the different types of attacks found in the anomaly IDS. In our proposed system, the buffer overflow attack is considering as the anomaly. Buffer overflow is the more general vulnerability exploited by attackers. The detailed description of the buffer overflow attack is described below. In programming and computer security, the buffer will confirm with the next neighbor node. If the RREQ will attain the destination node will transmit RREP message to source node. Source node transmit the data packet to nearby node or midway node. Check for anomaly behavioral data packet. If the anomaly behavioral nodes there in path creates an alarm. If anomaly behavioral nodes are not occurred in the path, it will verify that the anomaly nodes are present in network or not. If there is no anomaly node in network, it will generate an alarm. If anomaly nodes are present in network, it will forward data packet to next node or destination node. Output: detect the anomaly IDs in the mobile ad hoc networks. End algorithm. Fig 5 depicts flowchart of anomaly detection method. The anomaly detection method checks the anomaly behavior data packets which is received from the intermediate nodes. If the anomaly behavior nodes are not there in the path, then it checks for anomaly nodes in network. If it is present in anomaly behavior, then it generates an alarm, else it forwards to next node and calculates the false positives. Intermediate nodes receive the packet. Check for anomaly behavioral data packets. Overflow is an anomaly, where a program at the time of writing data to a buffer, overruns boundary of buffer and overwrites adjacent memory location. Buffer is defined as, it is a given size of memory taken to load with data. Say a program is reading strings from file like dictionary, it might discover a name of big word in English and fix that to be the size of its buffer. The difficulty occurs when files contain string more than buffer. This might arise legally, where a novel, big word is accepted into dictionary, or when hacker adds string to damage memory. In the buffer overflow attack, the additional data sometime holds particular instructions for action intended by malicious user or hackers. For example, the data could trigger a response that spoils files, changes data, or reveal private information. Algorithm 1, Aodv routing protocol. Input: initialization of source node and destination node. Source node will transmit RREQ, root request message to nearby node or destination node. If the RREQ will not attain the destination node, it. Conclusion. Usual intrusion detection contain a problem dealing with need of secure boundaries, threats from the cooperative node's need of restricted power supply, centralized management scalability and capability. Because these problems, they are encouraged to introduce well-organized intrusion detection system, which contain a novel method to recognize anomalous behaviors in the MANETS. The intrusion detection is a significant technique for security protection. It will give the better security for mobile ad hoc networks. In this paper, better intrusion detection technique depending on the anomaly detection is introduced. The anomaly intrusion detection method is executed on the zone-based Aodv routing protocol. This detection system will provide the enhanced security for the mobile ad hoc network. The parameters like energy consumption and packet delivery ratio are calculated, which give the better result as compared with the existing systems. Where 1 is total number of data packets received by every destination, 2 is total number of data packets produced by every source. So by using the above formula, the packet delivery ration is calculated. The proposed system achieves the PDR, packet delivery ratio, of 97%. It gives the better PDR as compared with the existing system's PDR, 95%. Throughput is the amount of data traveled successfully from one place to other in a given time period. The Fig 8 shows the performance graph of the throughput rate.